All right, we're back. We're on page 8 of notes 5 for Calc AB. We're talking about the mean value theorem a lot, doing review, mixed kind of questions. This happens a lot in calculus. It's a much more integrated topic or subject, I guess, where you don't get like these discrete notions like you solve this type of equation then move on. Like it doesn't really happen in calculus. You kind of have to know everything all the time, which is what I like about it. It's what some people find a little intimidating, but don't be intimidated. Just learn the material and you'll be fine. All right, let's take a look at this problem. So it says a continuous function f is defined on the closed interval from -5 to 4. The graph consists of a line segment and a curve that is tangent to the x-axis at x equals 1. Okay, you can see that in the picture. On the interval from -1 to 4, on the interval from -1 to 4, the function f is twice differentiable with f double prime less than 0. So I don't know, maybe that applies. Let's see what we're gonna do. Question number 1, or A, I guess. Is f differentiable at x equals -1? Well, I mean, you can look at the picture and you can just kind of see that, like, yeah, no, that it's not. So what we're supposed to do is use the definition of the derivative with one-sided limits to justify our answer. Okay, so what I'm going to do is, I mean, I guess first I'll just say, like, f is not differentiable at x equals -1. So f of x is not differentiable at x equals -1. All right, so somewhat mission accomplished. All right, now one-sided limits, limit definition of the derivative. I'm going to say, well, I shouldn't have put a period there, I guess. I'm going to say because, and let's look at the limit as h approaches 0 from the left of f of x plus h minus f of x over h equals, all right, so if h is approaching 0 from the left, then, oh, wait, hold on. I want -1s. I don't want h's here. And also, I mean, I kind of wish that I had used the other definition of the derivative because I think this argument would be easier to make, but didn't do it. So what are you going to do? Let's use this color. So -1, -1. All right. So if h is approaching 0 from the left and we go to the figure here, then what we're basically doing is we're kind of like sliding along the curve this way. And so on that interval, you can see that the slope of that curve would be, what do we go? Down 3 and over 4. So this, I'm just going to say, is -3/4. Now, I'm saying it's not differentiable. I mean, it's a sharp turn, so there's no way that it's differentiable. I don't really know what the curve is between -1 and 4, but I definitely know that, say, from -1 to +1, the slope of that curve is positive, which means I can say that, so how do I connect these? Because this is true, and I'll say while the limit as h approaches 0 from the right of f of -1 plus h minus f of -1 all over h. And so what I'm going to do is, since I can't actually find the value, I'm just going to say it's greater than 0. Because it definitely is, right? The slope is definitely positive. I didn't really mention it, and I'm not sure that everyone watching this would pick up on why these have the values that they have. So for example, the first one, we're starting at -1. And then since we're doing the limit as h approaches 0 from the left, so we're going to add a number to -1 that's a little bit negative. And so if you add a number to -1 that's a little bit negative, you get like -1.1, something like that. So that's going to put you over here, which is why we're saying the slope on that interval is the slope of that line segment, -3/4. Whereas when we look at the limit as h approaches 0 from the right, we're saying that we're going to add a tiny little positive number. So we start here, this is our -1, but we're adding a little positive number. So that's like -0.9, for example. So we're like over here. So that's why we use the slope of the line segment when we approached 0 from the left, and the slope of the like quadratic looking thing. I don't know, does it tell us it's quadratic? No, it's just a curve. We don't even know why we use the slope of the curve when we're approaching from the right. So I don't know if that was really obvious when I was doing it. Because that, while that is true, let's say, again, I like to jump in and put like a period at the end of things when I probably shouldn't. Let's say, therefore, the limit as h approaches 0 of f of -1 plus h minus f of -1 all over h does not exist. And for a function to be differentiable, that would need to exist, right? Because that's the limit definition of the derivative. So not differentiable. So it always takes longer to answer questions than you think it's going to in calculus because you have to come up with these like really good explanations. All right, let's see. For how many values of a, -2 is less than a is less than or equal to 4. So a, I guess, could be 4 if you wanted. Is the average rate of change. So average rate of change is algebra 1 slope. So as soon as you see average rate of change, right here, average rate of change, you know it's algebra 1 slope. So average rate of change of f on the interval from -2 to a is it what? Equal to 0. Okay, so we're going to start at x equals -2 and then give a reason for your answer. Is this a mean value theorem problem? So I don't know yet. All right, so -2. Let's use, I don't know what color to use. I'm going to use orange, I guess. So here's -2. And then what I want to do is if the slope is going to be 0, that's a horizontal line. So I'm just going to draw a horizontal line through the figure. And let's let the magic take over and turn that into a line. And you can see that there's actually 2 values, right, where the horizontal line is intersecting. One of them looks like it's at exactly 2. We have no way of knowing. We have absolutely no way of knowing on the first one, which is somewhere between -1 and 0, but whatever. So I'm going to say that there are 2 values. So 2 values. There are 2 values of a. Should I just put a period there? I think I'm gonna. There are 2 values of a, and then nope. I should never stop putting periods at the end of things. There are 2 values. I need to justify it, right? So give a reason. So it doesn't say that I need to like come up with a formal argument. So I'm just going to come up with an informal argument. I'm going to say because the horizontal line through. So because the horizontal line through -2, f of -2, let's say, intersects the curve twice on the interval. Twice on the interval. I mean, you could probably just put the interval. -2 to 4, the open interval, so -2. So I'm going to say that that's my reason. I think it's good. Is this a mean value theorem problem? This is not a mean value theorem problem, right? So first of all, the function is not differentiable on either of the intervals that you would have. You would have like -2 to, I don't know, say -0.2 or -2 to +2 maybe. Function's not differentiable, so mean value theorem doesn't apply. But also, even though this feels like the setup of the mean value theorem, it's not asking you to use the mean value theorem. So I'm going to say in parentheses, this is not really an MVT problem. It feels like it, but it's not. Maybe make that an exclamation. I like to use exclamation points more than I'd probably admit. All right. So there's 2 more parts to this. How detailed do I think they are? You know, I'm going to stop the video here. I'll come back in the next one. We'll answer the next 2 parts. I don't want these to run until like forever. So I will see you in the next part, and we will finish off this page. So see you then.